A pleasant day, everyone. Welcome to our session for today. So, today I'm going to discuss integration by substitution. So, by integration by substitution, we can do it uh, for algebraic functions and also other functions, the trigonometric functions, exponential functions, and all those functions that we had mentioned and discussed in our differential calculus. But in this video, I will focus more on the integration by substitution of algebraic functions using power formula. Okay, so at the end of the session, you should be able to derive the general power formula, identify integrals that can be solved using the general power formula, evaluate integrals using general power formula. Okay, so integration by substitution. But for first one is algebraic functions. So I will only solve algebraic functions for this video class, and then the other functions will be discussed in our other video. Here we have the general power formula. So actually it is just taken from what we had discussed earlier from the basic formula class, but this time we generalize that formula. So the general formula is this integral of u to the power n times du equal to u to the power n plus 1 divided by n plus 1 plus c. If you can still remember in our previous discussions, we use x here, x to the power n, right? Now we will use u to the n, and we will use this formula in solving integrals that can be solved using substitution method. Okay, and take note, class, from this formula, n should not be equal to minus 1, because if n is equal to minus 1, so this will be minus 1 plus 1 equal to 0. So the denominator here becomes 0. So we know that any expression, any number divided by 0, that is always undefined. So we can apply this formula only when n is not equal to negative 1. Okay, for example, if you're given, say, integral of the quantity 3 times x minus 4 raised to power 4 dx. Okay, so can we solve it using the basic formula? So it's not in the form now of the basic formula, like the a dx equal to x plus c, and the other one is x to the n. So in this case, class, we are going to use this method substitution. So from this given, we know from this given that our n is equal to 4, right? So from the formula, we will use, from the formula, general formula, which is integral of u to the n du is du equal to u to the n plus 1 divided by n plus 1, then, sorry, this is n plus 1. N plus 1, then plus c. Okay, so this is the general power formula. Okay, so if our n is equal to 4, then our n plus 1 is equal to 5. So n plus 1 is equal to 5. So here we are going to let u, so we're going to let u equal to this. So our u is 3x minus 4. Okay, so if our u is equal to 3x minus 4, so we have now u to the n. So this will be u to the n. So we can now rewrite this as integral of, now we're doing substitution class, u to the n. U, where our u is equal to this, but now we will use substitution, so we replace this by u. Then to the n, we will use the same n. R is 4. All right, then times du. So we have to find what is our du. So from here, from u, so if our u is 3x minus 4, then our du, from our differential calculus, when you find a derivative, the derivative of this. So when you take the derivative of this, so you have dy, the derivative of u with respect to x, right? So we do it this way. Okay, I will write it properly, class. So du over dx, meaning we just take the derivative, derivative of u. So this will be 3, right? Because derivative of 3x is just 3. Derivative of constant is equal to 0. But what we need here is du. From the formula, we need du. But here we have du over dx. Okay, so du over dx. So it means that to solve for du, so du is equal to, just multiply both sides by dx, or just cross multiply dx. So 3 dx. All right, so in this case, class, you see this term here, this part, this quantity 3x minus 4, we let this be equal to u, so we replace this by u. Then we have here dx. So we need also to we need also to substitute dx in terms of du. Okay, so we will replace everything in terms of u and du. So in this case, we have du equal to 3 dx. So we need to solve for dx here. So what is dx in terms of du? So we have to solve for dx. So to solve for dx, we divide both sides by 3. So therefore, we have du, divide this by 3. Okay, so the right side, when you divide this by 3, this becomes dx. Okay, so what we need to do now is you replace dx, because we replace this one by u, then we replace this in terms of du. So our dx in terms of du is simply du over 3. So times, so this becomes du over 3. So is it now in the form of our general power formula? So almost. Now we just need to do something, mathematically. So we can rewrite this multiplication class. So we can rewrite this as, and this one is denominator, so this is constant, so you can put it outside the integral sign. So you can write this as 1/3, because du over 3 is just the same as 1/3 du, right? So we rewrite this, then we isolate this because this is a constant. So we have the integral of, so you have u to the 4th power, then times du. Okay, so this is now in the form of general power formula, u to the n du equal to, so this is the equivalent. Okay, so applying this formula, So we can rewrite this as 1/3 times u to the n plus 1. So our our n is equal to 4, then n plus 1 is 5. So u to the power 5 divided by 5, then plus the constant of integration, which is c. Or, so I'll put it here, class. We have, so 1 divided by 3. This one, class, u to the 5 over 5, the same as 1 over 5 times u to the 5th power, or u to the power of 5. So in other words, you just multiply the numerators, you multiply the denominator. So this becomes 1 over 15. Okay, so 1 over 15 times u to the power 5, then plus c. Okay, but our u is equal to this. This is our u. So substituting, you substitute the value of u. So you will get, so 1 over 15 and times u, where our u is equal to 3x plus 4, 3x minus 4, and then raised to a power 5. So this power, which is 5, then plus c. Okay, so this is our answer, class. Any question? So I will give you some more examples of this one, solving integrals using substitution, in our next video. Okay, so thank you very much. Wait for the next video, class, for our next example. Bye.